So how do I show that these two are equivalent? The bottom two. What happens if it's planar? If it's planar, then it has a vector valued function. In particularly, z is in the plane, so z is 0. If I was to find a parameterization of a function r of t, we're going to let x be x in our usual fashion, y is f of x, and z is 0. Okay? Now why is this? Because it's planar. And this planar function has the form f of y is equal to f of x. So what's x? It's x. What's y? It's f of x. And z is squished down into the plane. Sure, let's go through mechanics. Let's use this guy. So I'm going to need the first derivative, r prime of t. That's 1 f prime of x and 0. I'm going to need the second derivative, r prime prime of t. That's 0 f prime prime of x, the second derivative. Because when we're taking the derivative of vector valued functions, it's the derivative of each one of its components. Change this parameter to x, because that's now our input value. There we go. Then I'm going to need to cross the two. I'm looking for r prime cross r prime prime. So then that's going to be a vector. When I block out my first column, whoosh, whoosh, that's 0. Great. Block out the second column, whoosh, whoosh, that's 0. Block out my third column. Looks like I'm going to have the second derivative of f of x minus 0. Great. So then when we take the magnitude of that guy, the magnitude of r prime prime cross r prime cross r prime prime. Remember, the order matters in the cross product. How does it matter? Gives you the negative. Right. So there we're at. That's the square root of 0 squared plus 0 squared, and then the second derivative squared, which does happen to be the absolute value of the second derivative. So we're seeing that we're on a really good path for getting our plane form of curvature. So now we need the magnitude of the first derivative, r prime of x. That is 1 squared plus f prime of x squared. Great. And then switching to rationals, plugging it into this form, we're going to find that our curvature in the plane is the magnitude of the second derivative over the magnitude of the first derivative cubed. So I'm switching to rationals, and this is 1 plus f prime squared, all of that, to the 3 halves power, and then you're done. It has been shown